and each one will be attended to. So to start our session for this afternoon, our first speaker this afternoon will be Mr. Daniel Ehrenreich, who will be talking about how AI and ML enhance the productivity and expand the cyber attack surface. So Daniel is a consultant and a lecturer acting at Secure Communications and Control Experts, periodically lecturing at industry conferences of cyber defense for individual control systems. He has over 30 years of experience with ICS systems for electricity, water, gas, and power plants as part of his activities at Tediran, Motorola, Siemens, and Waterfall Security. And he has also been reselected for the fifth time as the chairman for ICS CyberSec 2020, taking place on November 2nd, 2021 in Israel. So I will hand over the stage to Daniel, who will proceed with his presentation.
Good afternoon. It's a pleasure for me to be here at AI Plus Business Asia Virtual Conference 2021. My name is Daniel Ehrenreich. I'm a consultant and lecturer at SCCE, Secure Communication and Control Experts. And my presentation today will focus on artificial intelligence and machine learning, which enhance the productivity and expand the cyber attack surface. I bring over 45 years of industrial experience. For many years, I work with large international companies in broad range of industrial high-tech topics. In recent 10 years, I'm focusing on cybersecurity and also act as consultant and lecturer, cybersecurity workshop trainer, ISO 27001 auditor, and also participate in the 62443 committees for industrial cyber security. When we are speaking about industrial applications, there is about a range of 10 major applications or verticals dealing with electricity, water, sewage and transportation, oil and gas, nuclear and chemical plants, food and beverage, even building and energy management and cellular communication networks, heavy metal manufacturing, and recently also smart cities and public safety control. All these belongs to the family of industrial control systems. Some people call it operation technology, which is fine, and other people call it cyber physical systems. So all this range of vertical applications is very much relevant to cybersecurity and very much relevant to introduction of AI and ML for improving the process for these vertical applications. I would like to show here just one example of industrial Internet of Things and Internet of Things devices, which in this case are installed in the building, or at home. A broad range of sensors, cameras related to sensor gates and variable devices, and you name it, monitoring air conditioning, light, temperature, liquid flow, broad range of sensing devices are being installed. The data from these devices is communicated to some type of computer which is analyzing the data, and obviously it introduces improved processes which are critical for achieving better operation, more convenient management, and so on. When speaking about industrial control systems, I would like to focus here on one specific application, which in this case is the large water pump operated by water utilities, and on the left side you can see quite many sensors which are monitored by a programmable logic controller, and the data is forwarded via the internet through some type of expert service provider, and that service provider is, after analyzing the data, is sending feedback to the operator and advising him about problems, about operating performance, and so on. Similar but different architecture on the right side, where you have just one or two sensors which are communicating over cellular network directly to the same service provider, and again the feedback from the service provider to the operator will deal with the performance and the detection of malfunction. This picture is very, very important because we see here some major risks, and I'm going to talk about it more later. The sensor which is installed at pump can be manipulated. The communication network which is sending the data to the expert center can be manipulated. The communication data which sends as a feedback to the operator can be manipulated. Broad range of incidents can happen. Why? Because these networks and these devices might not be correctly protected. Just to remind all of us why we have these problems related to the Internet of Things and the industrial Internet of Things. We all know that these devices are low-cost devices, legacy type product. They have very light computing capability. For sure, they were never designed for encryption, authentication. You cannot install an antivirus protection on these devices. They are very, very simple and also low cost because that's what people want to buy. Most of these devices lacking of standard protocol. In many cases, we are not even sure which company produced them. We are unable to do configuration of the devices or replacing username, password, or we don't want to do it because we don't like to touch these devices because we don't know what can happen. So these are the risks that are contributed by the IoT and IoT, and I will come back to that later. When we speak about risk factors, obviously it's calculated by probability, multiplied by impact, and multiplied by the known vulnerability. It's a factor. You can put this in a scale of 1 to 5 each factor, and you will receive the risk. We speak about internally generated attack when somebody is penetrating to the facility. It can be an employee, it can be a visitor, it can be a hacker, somebody who has an interest and motivation to cause damage to your facility. It can be an externally generated cyber attack, usually starting via the internet and social engineering and so on. We all know that these attackers may operate 100 to 200 days before they are detected, a major problem, and this need to be taken into consideration. And also not forget the supply chain related attack. We are buying products from distributors, downloading software from the internet, and not forget the COVID-19. Why? Because we have no choice but to allow remote service providers to connect remotely to our facility and perform the maintenance because they cannot travel, they cannot fly from abroad. So you can see here the three major attack vectors. When we speak about the types of attack can be accidental attack, meaning that somebody is creating an attack. For example, it can be a denial of service, it can be a ransomware, or any kind of attack. Okay, it's the accidental attack. It can be an opportunistic attack. Just somebody detected a 0-day, or somebody get access to a ransomware, and he doesn't really care about who is going to attack. Just cause some damage, and that's all. Usually these attackers don't have a strong motivation, don't have resources. They just want to do some attack, and usually these attacks are not severe. Finally, we need to talk about the targeted attacks, which are initiated by hostile countries. Usually we call these attacks APT, Advanced Persistent Threat, and it means that these attackers finally will be successful. What the attacker can do? Obviously, a broad range of activity. He can attack the HMI, he can attack of the plant, obviously get some access. What happened in Florida, the Oldsmar incident, we all remember that a few months ago. The HMI was attacked, and then some manipulation happened on one of the critical parameters. The attacker may attack the process itself in the SCADA, DCS, ICS type architecture. The attacker can internally access directly the PLC, RTU, or IED operation, intelligent electronic device, and manipulate the process, manipulate the data, manipulate the wiring of sensors to these devices. Broad range of things can happen. Attacker can access the data. In the data which is transferred over the internet to the IT zone, and already create some type of manipulation of the data. Few minutes ago we talked about the data which is transmitted from the pump to the expert center, and damage can happen. And again, I would like to mention, because this is critical, manipulating the installed sensor, replacing the sensor, detect the wire, disconnect the wiring, or just moving the location of the sensor, whatever you can think about. Another type of attack can happen. In this picture you can see a nice architecture of a main control organization which is connected to some type of remote zones. It can be IoT device, it can be a smaller plant, it can be a remote wind sensor, and so on. And these remote locations are usually less protected, I mean about physical protection, than the main facility. In many cases, the VPN link from these devices to the main system is usually trusted, so people think it's okay, but no, it is not okay. It can be manipulated, and so on. So the conclusion of this picture is that the risk is always dependent on the least protected zone. What does it mean? That in order to mitigate the risk, you must have periodic inspection of these sites. How we are protecting our facility? Definitely we need to deal with the PPT triad, dealing with people. Policy and technology. People is training people, and they run drills. Policy is have strong policies how people should behave, and obviously technology is the last one, because usually upgrades are very difficult. Just to remind all of us, this triangle which says that operation safety cannot be assured without cybersecurity. This is very, very critical. And cybersecurity cannot be assured without physical security. So on this slide, I show that first you need to assure physical security, wiring, location of sensors, location of controllers, and so on. Cyber security by electronic measures, and then hopefully you improve or reduce the risk of safety. So how AI and ML is affecting these activities? AI performs analyzing the specific inputs, values, and conditions, run sophisticated calculations, perform functions which humans cannot do, and even capable of performing tasks at a very high speed without being requested. But AI cannot operate alone by itself. It must be supported by the machine learning. The machine learning is a subset of AI. It is collecting data, analyzing the baseline, creating a picture of what is normal, and based on that identify condition which is deviation from the normal. ML processes can be integrated with cloud-based expert processes, similarly what I earlier showed about the water pump. Okay, so their algorithms help improving the effectiveness of the computerized processes and also detect anomalies which may indicate that some failure is coming. Speaking about the benefits, the major benefits of the AI and ML, so the AI and ML process is the basic for Industry 4. We all know Industry 4 collecting a lot of data and analyzing the data. Okay, this is very, very important. Big data analysis and so on. However, we need to remember, and I will repeat it again at the end of the presentation, that AI and ML are increasing the attack surface. Why? Because they are collecting a lot of data from remote sensors, analyzing the data, and if something goes wrong, some intervention, some manipulation, then obviously the attack surface is increased. It may lead to unexpected shutdown of the process, maybe even damage to machinery, and in worst cases it can be even hurt people because of the incident. Let's talk a little bit about anomaly condition detection. Anomaly condition detection means detect unusual situation, deviation from the baseline. It can be a passive scanning, which are done already for many years. Passive scanning, collecting data, analyzing the data. In recent years, some vendors started to introduce active scanning, which allow collect more data and better analysis of what can happen in the field or what can happen with the sensor and so on. So it will help you to reach conclusion about what can happen. I would like to show here just one picture of how AI and ML are helping us to detect malfunctions or unusual conditions caused by cyber attack. So on the left side you see a picture of a generator, but it can be a water pump or any other machinery. The upper channel with the red boxes is the original industrial control system, which is collecting data and analyzing the data, but this is a legacy type device. The bottom channel in the green color, we are installing an additional sensor, we are installing an additional analyzer which performs high-speed sampling and more granular inspection of the situation. At the SCADA ICS DCS control center, these two channels are being compared, and if there is unusual situation, then obviously it will be detected, and somebody will have to take care of it. We need to reach a conclusion that cybersecurity must evolve, it meaning monitoring a lot of data, adjusting the baseline. The security process, we must categorize it by asset criticality, because we cannot protect all zones in the plant using the same level of cybersecurity. We must identify the risk, internal, external, supply chain, what I mentioned, and also identify risk caused by negligent action of authorized people. All these are risks. How can we improve the cybersecurity? So we need to determine the potential impact, what can happen not in the plant, but in each zone of the plant. We need to have the right sensors. We need to have the right AI and ML where applicable. We need to have a strong incident response team which knows exactly how to respond. We need to have security controls according to ISO 27001 standard, or according to the ISA 62443 standard for industrial control system. We need to implement this control, monitor constantly that these controls are in place. And actually, the goal is always to be better prepared in order to expect the unexpected, what can happen, and always be a step ahead of the attackers. I would like to briefly summarize of what can be done, or how to protect your industrial facility. Obviously, you must start with correctly designing the organization architecture, and remember, top priority operation safety and reliability and cyber defense are all critical. And as I mentioned earlier, physical security, not forget it. Perform segregation about independent zones and zones which have a different level of criticality. Segregation does not mean air gap. However, it means that you need to have secured integration, firewall, DMZ, data diode, whatever is required, but it needs to be done security. All devices, computers, and network components must be updated. We often receive information from the vendors about vulnerabilities, and updates and patches are coming frequently. For IT, it is very simple. For ICS, it's not so simple. You need to know how to do it. For remote zones, where it is possible and necessary, you need to deploy encryption of the channels and authentication of all connecting devices. Why it is important? Because somebody may disconnect a device, reconnect another device, and perhaps connect a malvertised device. So you need to be able to detect it for sure in order to be on alert when a cyber attack happens. You need to periodically review the installed hardware, software, and updates. And again, don't forget physical security. Make sure that that people who are not authorized, they cannot access this sites. Very important, your team need to reach in-depth understanding of the process and monitor all the sessions. When I say process, it's the control process, but also the AI and the ML processes which are included in the entire plant operation. In order to be able to do all these great things, you need to perform periodic training and drills to all involved employees, to everyone. Okay, this is very, very critical. And finally, you need to manage the skills in your organization, IT people, industrial control team people, they must assist each other and make sure that the knowledge and expertise is available related to hardware, software, cyber technologies, AI, ML, everything. Collaboration is absolutely mandatory in order to achieve the goals. Finally, I would like to remind the most critical messages related to a cyber secured operation of your plant. Put security and safety goals into your specification. This is very, very important because if you not specify, if you not require, you will never have it. Deal with vendors, leading vendors, international vendors who take operating security and safety seriously. This is critical. Do not compromise on the requirements. Yes, sometimes you have to pay slightly more in order to acquire a top class solution. Do not compromise, because when the attack will happen, it might cost significantly more to your organization. Finally, always be ready for the challenges and surprises, because the capability of the attackers always evolve. This ends my presentation. I'm open to some questions to answer them as they are coming in. But anyway, on the last screen and also in the bottom of every slide, you have my email address and contact details. Anytime after the conference, feel free to send me a mail and I will do my best to respond to you. So thank you very much, and wishing you continue the conference.
Yes, thanks, Daniel. It's a very interesting take on how AI and ML enhance the productivity and expand the cyber attack surface. I haven't seen any questions come in to the audience. As you mentioned, should you have any questions for Daniel, do feel free to drop him an email. Any mail to reach him through LinkedIn and here on the platform. Daniel, I think you did have something that you wanted to add as well, so you may go ahead.
Sure. First of all, it's a pleasure for me to be here again. And I really want to encourage people to study industrial cybersecurity. Industrial cybersecurity is a role for experts in the area of industrial control. This type of training, in probably the 15, 25 hours, it's possible to learn. It's suitable for IT people, for industrial people who need to learn the topic of cybersecurity, and finally also for managers who need to make correct decisions related to how to protect their facility. So anyone interested to learn this topic, feel free to drop me a mail and I will do my best to advise you where and how it is possible to learn. So see you next time at the next conference. Bye-bye.
Thanks again, Daniel. It was very great having you here at this event, and we definitely look forward to having you as well in our future events. Thank you so much. So as of right now, we will be moving